Namaste students, myself JV and Dr. Kiran Yadav. In this session I will discuss about PN junction diode. When N-type and P-type dopants are introduced side by side in a semiconductor, a PN junction or a diode is formed. So for making a PN junction diode, a piece of semiconductor is taken, and in one part of the semiconductor doping of N-type impurity is done, and in another part P-type doping is done. So basically in the same semiconductor two regions are formed, one with N-type semiconductor and another with P-type semiconductor. So this device or this arrangement is basically called PN junction or diode. Okay, so in N-type region there will be a free electron, and in the P-type region there will be a hole. There are three reasons in which a PN junction diode operates: PN junction in equilibrium, PN junction under reverse bias, PN junction under forward bias. PN जंक्शन को जब हम सर्किट में कनेक्ट करते हैं, if we connect the P-type semiconductor to the positive terminal of the battery, then it is known as forward bias, and if we connect the P-type side of the PN junction to the negative terminal of the battery, then it is known as reverse bias. In order to understand the operation of a diode, it is necessary to study its three operation regions: equilibrium, reverse bias and forward bias. Current flow across junction, which is also known as diffusion. So in N-type region there are majority carriers which are electrons, and in P-type region the majority carriers are holes. In N-type region the minority carriers are holes, and in P-type region the minority carriers are electrons. Because each side of the junction contains an excess of holes or electrons compared to the other side, there exists a large concentration gradient. Therefore a diffusion current flows across the junction from each side. अब आप देखेंगे N-type में इलेक्ट्रॉन्स ज़्यादा हैं और P-type की साइड में होल्स ज़्यादा हैं, तो क्या होगा, इलेक्ट्रॉन्स P-type साइड की तरफ जाएंगे और होल्स N-type साइड की तरफ आएंगे. Here Nn is the concentration of electrons on N side, Pn is the concentration of holes on N side, Pp is the concentration of holes on P side, Np is the concentration of electrons on P side. तो एक डिफ्यूज़न मोशन सेट हो जाएगा जिसमें कि इलेक्ट्रॉन्स N साइड से P साइड की तरफ जा रहे हैं और होल्स P साइड से N साइड की तरफ आ रहे हैं. इसे ही डिफ्यूज़न बोलते हैं, और इसी मोशन की वजह से जंक्शन के अक्रॉस करंट फ्लो होता है. जंक्शन किसको बोलते हैं? जो N-type और P-type दोनों जहाँ कंबाइन होते हैं उस पॉइंट को जंक्शन बोलते हैं. जैसे आपको एक डॉटेड लाइन दिख रही होगी इस डायग्राम में, वो जंक्शन है बेसिकली. उस डॉटेड लाइन के लेफ्ट में आपका N-type सेमीकंडक्टर है और राइट में P-type सेमीकंडक्टर है. तो इस लाइन पे दोनों सेमीकंडक्टर्स कंबाइन हो रहे हैं, दैट्स व्हाई इट्स कॉल्ड जंक्शन. अब डिप्लीशन रीजन कैसे फॉर्म होती है? As free electrons and holes diffuse across the junction, a region of fixed ions is left behind. This region is known as the depletion region. N-type में मेजॉरिटी कैरियर इलेक्ट्रॉन्स हैं एंड P-type में होल्स हैं. तो N-type साइड की तरफ बहुत सारे फ्री इलेक्ट्रॉन्स आएंगे एंड देयर विल बी लॉट्स ऑफ फ्री होल्स इन द P-type रीजन. धीरे धीरे डिफ्यूज़न का प्रोसेस शुरू होता है और N-type साइड के जो होल्स हैं वो P-type की तरफ मूव करते हैं, और P-type के जो होल्स हैं वो N-type साइड की तरफ मूव करते हैं. मूव करके वो सेंटर में एक रीजन बना लेते हैं जिसे डिप्लीशन रीजन बोलते हैं. इस रीजन में क्या होता है, N-type की तरफ पॉजिटिव होल्स इकट्ठे हो जाते हैं और पी टाइप की तरफ इलेक्ट्रॉन्स इकट्ठे हो जाते हैं। इस रीजन को डिप्लीशन रीजन बोला जाता है। करंट फ्लो अक्रॉस जंक्शन ड्रिफ्ट। The fixed ion in depletion region create an electric field that result in a drift current। ठीक है, इलेक्ट्रिक फील्ड प्रोड्यूस होगा जिसकी वजह से एक ड्रिफ्ट करंट जनरेट होता है। Current also flows across junction due to equilibrium. At equilibrium, the drift current flowing in one direction cancels out the diffusion current flowing in the opposite direction, creating a net current of 0. So the charge profile of the p-n junction is shown in the diagram. So basically this is p-n junction diode in reverse bias. Up to now we were studying p-n junction diode in equilibrium when there was no biasing. Now to connect the p-n junction in reverse bias, we have to connect the p side to the negative terminal of the battery and the n side to the positive terminal of the battery. When the n-type region of the diode is connected to a higher potential than the p-type region, the diode is under reverse bias, which results in wider depletion region and larger built-in electric field across the junction. When the diode is reversed bias, there is one application which is voltage dependent capacitor. The p-n junction can be viewed as a capacitor by varying VR. The depletion width changing in capacitance value. Therefore, the p-n junction is actually a voltage dependent capacitor. This is important. What is the use of p-n junction diode in reverse bias? So you can say it is used as a voltage dependent capacitor, where if we change the depletion width, the capacitance of this capacitor will change. This is the formula for voltage dependent capacitance, and these equations describe the voltage dependent capacitance. Voltage controlled oscillator. A very important application of a reverse bias p-n junction is voltage controlled oscillator, in which an LC tank is used in an oscillator. By changing VR, we can change C, which also changes the oscillation frequency, whose formula is given in the shown here also. Now p-n junction diode and forward bias. When the n-type region of a diode is at a lower potential than the p-type region, the diode is in forward bias. The depletion width is shortened and the built-in electric field decreased. Under forward bias, minority carriers in each region increases due to the lowering of built-in field potential. Therefore, diffusion currents increase to supply these minority carriers. These are diffusion current will increase in order to supply the increase in minority carrier, and the mathematical equations corresponding to this are shown above. So this was about diode in forward and reverse bias. That's it for this session. We will continue further discussion in the next session.